Hi guys, today we will be discussing about the fat metabolic process. We have started from the previous lecture about the fat metabolic process, and today we will be going to discuss about the beta oxidation process. Basically, this process is meant for energy liberation from the fats, and basically, what are the steps in it? Uh, Breakdown of the fats into the acetyl-CoA, and during that process of beta oxidation FADH2 is formed, that is a oxidative phosphorylation process, and NADH is formed. Again, it's an oxidative phosphorylation process. So in this process, the long chain, as you know, the fatty acid structure that consists of the long chain of the carbons, the long chain of the carbons of the fatty acid that breaks into two carbons at a time to form the acetyl CoA. This is the two carbon at a time, right? To form the acetyl CoA. So, for example, if you have a 18 carbon chain fatty acid, that the two carbon will be separated into acetyl CoA, remaining 16 carbon. So that 16 carbon that will undergo another beta oxidation process. So again, two carbon will be cut down from there to form the acetyl CoA, and remaining 14 carbon chain will be there. So we will be looking at this process, how that happens. So look at this one, acetyl, first of all, acyl CoA, right? Look at this one, acyl CoA. This is acyl CoA, right? What does it mean? This is a fatty acid attached with a coenzyme, as coenzyme, right? COOH and CH2, 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 CH3, and the terminal is a CH3, that is the fatty acid. So at place of the COOH, there is a acyl attached to that one, that is CoA is attached to that. So acyl CoA is formed, right? So there are several enzymes. Basically, four steps are involved in this beta oxidation process. There are four reactions, and each reaction that is catalyzed by the enzymes. So the first reaction that starts with the acyl CoA and the acyl CoA dehydrogenase enzyme that works on this one to form it as a beta enoyl CoA. And you know that dehydrogenase belongs to the class of oxidoreductase. So the first product that is generated, that is a beta enoyl CoA. How? What is the change? Double bond is generated on second carbon. This was the first carbon. This was the second carbon. This is called alpha carbon. This is called as the beta carbon. So at the beta carbon, there is a generation of the double bond. So hydrogen is actually removed. So it is called as the oxidation process when the hydrogen is removed from the process. So beta enoyl CoA will be working there, and as a result of the oxidation, uh, uh, this beta enoyl CoA is formed by removal of the hydrogen. Then on this one, uh, enoyl CoA hydratase, as the name indicates, that is hydratase mean addition of the water. So this enzyme is doing the addition of the water. So look at this one. This is the addition of the water. So one as you know that water that consists of H and OH, right? So you can see here, this is the OH that will be at the double bond position. This one, this one. This is the position at which this water that will be adding. At that point, OH, and at that point, there will be addition of H and breaking down this double bond. So OH and H, that is added here to form the beta hydroxy acid acyl CoA, beta hydroxy acyl CoA, right? Then again the dehydrogenase. At the first step, the dehydrogenase was involved, and at this stage, again a dehydrogenase is involved. When at the first stage the dehydrogenase was involved, that will be turning FAD into FADH2, and you know that this FADH2 that is equivalent to 2 ATPs. And at this stage where this dehydrogenase is involved, this NAD is actually converting into NADH2, and this NADH2 that is actually equal to 3 ATPs, right? So beta hydroxy acyl CoA that is converting into keto beta keto acyl CoA, right? So look at this one, that is the previous step, that was the oxidoreductase class dehydrogenase. So that is again an oxidation process. So in the oxidation process, what is happening, this OH, this O, from this OH, hydrogen is removing. From this OH, hydrogen is removing. So it's an oxidation process. It's an oxidation process. So look at this one. The hydrogen have been removed from that point. So at the last stage, beta ketoacyl CoA that is acted upon by the thiolase enzyme. Thiolase enzyme, that is a step, that is a breakdown enzyme. So this beta keto acyl CoA that will be going to break down into two substances. One is the acetyl CoA, as we talked about. It's a 2-carbon compound, acetyl CoA, and it will be two-step minus. Two-step minus mean if the initial point, at the initial point, this acyl CoA is of 16 carbon, so it will be 14 carbon. It will be 14 carbon. That will be 2 steps cut of that, right? If the reactant, if this reactant is of 20 carbon, so it will be of 18 carbon, and this will be 2 carbon. So this is a whole reaction for the beta oxidation for the energy liberation. So we are looking each step in detail again. That was the summarized point. We are looking quickly each step of the reaction. First of all, we have started with the acetyl CoA, right? This is the reaction, acyl CoA, right? So at the first oxidation step, acyl CoA dehydrogenase will be acting. FAD is converting into the FADH2, and as a result, beta enoyl CoA that will be formed. How the double bond will be generated at the beta position, right? So puts in this enzyme dehydrogenase puts in a double bond, oxidize CC bonds to double bond, and produce FADH2. This is the first reaction. In the second reaction of beta oxidation, beta enoyl CoA that is produced, that is actually hydrated by the enoyl CoA hydratase, and you can see here this is a hydration point. As a result of that, beta hydroxy acyl CoA that will be formed, and this water H and OH that will be added actually at the this points at the double bonds. So adds water forming the beta hydroxy products. Uh, then beta hydroxy acyl CoA that will be again oxidized. That will be again oxidized. This will be again oxidized. We can see here this is going to oxidize by the beta hydroxy acyl CoA dehydrogenase enzyme. Again, the dehydrogenase enzyme is there. All right. So beta keto acyl CoA is formed. You can see the keto substances here due to the presence of oxygen, and hydrogen is actually removed. So oxidize the secondary alcohol to ketone. A ketone is formed. Oxygen containing groups and produce NADH because the hydrogenase is there. And this finally beta keto acyl CoA due to the action of the thiolase enzyme that is breaking down actually the long chain molecule into the two molecules. One is the acyl CoA, it's a two carbon substance. This is acyl CoA, it's a two carbon substance, and other is the acetyl CoA, and I have told you that will be 2 minus from the acyl CoA that was started in the first reaction. If the first reaction have 18 carbon, you have started with the 18 carbon fatty acyl, so it will be 16 carbon acetyl CoA. So use another CoA that will go another beta oxidation reaction for energy production. So that's all for the reaction. In the next lecture, we will be talking about the energy that is generated through this process. So we are closing our lecture here. Thank you very much.